Now here I will start the discussion with the given problem. Now look at this problem carefully. Look at this problem carefully. This is given figure. How is the figure? In this particular case, this is 1s, 1s, 2s, 3s, 1s. What is s? S is nothing but Siemens. This ohm is the unit for impedance, and mho is the unit for admittance. These are the given things are the admittances. Sometimes impedances may be given, sometimes admittances may be given. If the impedance is given, we have to find out its reciprocal. Suppose this is the impedance is given 1 ohm, 1 upon 1. That will be the 1 ohm. Is it right? But here the values are given in terms of the mho. This mho. And mho can be named as a Siemens. This is one and the same. We can write it as a mho or we can write it as Siemens for admittances. This is the admittance. Given thing is the admittance. Values may be given in terms of the impedances or maybe in terms of the admittances. I have taken one problem related to the admittances and other problem I will take related to the impedances. Is it right? Now this is the given figure. First thing what we have to do. First thing we have to mark the nodes. This is node A, this is node B, this is node C, and this is the node D. Out of this marked node, select one node as a reference node. I have taken this node as a reference node. Now, mark the separate name for the separate branch as well as assume the separate current for the separate branch. In this case, this is 2s branch. This is I have taken this as branch number 1, this is branch number 2, this is branch number 3, this is branch number 4, and this is the branch number 5. This is 1, 2, this is 3, this is 4, and this is 5. Here we have, which I have given the names, branch number 1, branch number 2, branch number 3, branch number 4, and here is the branch number 5. Be careful, your concentration is expected. In this case, this current I have shown as it is, this current I have shown as it is. Just I have taken this direction downward, forward, downward, forward, downward, and randomly. I have chosen this directions randomly. There is no logic behind choosing the direction. You can choose these directions randomly. Now, from this given figure or from this available figure, from this particular figure, we will prepare its graph, and this graph is nothing but the oriented graph or directed graph. Look at how is the oriented graph. This is node A, this is node B, this is node C, and this is the node D. Is it right? Then this is the branch. This is the branch. Here it is, we have taken its current forward. This is branch number 2, this is the branch number 4, this is branch number 4, it is forward. This is the branch number 1, it is downward. This is branch number 3, it is downward. This is branch number 5, it is downward. And all these nodes we have shown. This here already we have discussed how to find out the oriented graph for the given figure. This is the given figure. For this particular figure, we are marking the directions of the current and we are finding this particular portion of the graph, which is nothing but the oriented graph. Once we know the oriented graph, now we will prepare its a reduced incidence matrix. This is the given figure. For this figure, we have prepared this graph, which is nothing but the oriented graph. This graph has the 4 nodes, 1, 2, 3, and 4. But here, look at the number of rows available in this particular matrix. We have only the 3 rows. Means here, we have taken this node as a reference node, and for this particular node, we have not prepared its row or we have not prepared its matrix row. Is it right? Now, this will be the node A. This is first row. The second row is the node B. This third row is the node C. How are the entries? Now look at, I will discuss about the row 1 or this node 1. At this node 1, this is outgoing, this is outgoing. This here, its entry will be +1, +1, remaining entries will be 0. For node B, how are the entries? This is incoming, outgoing, outgoing. Means 2, branch number 2 is a -1. This is 3 is +1, 4 is +1, 3 is +1, 4 is a +1, and this entry will be 0. Similarly, for the node C, branch number 1, 2, 3 are not attached, that's why its entries will be 0, 0, 0. Branch number 4 is incoming, that's why its entry will be -1. And this branch number 5 is outgoing, that's why its entry will be +1. Means here, for the given graph, we have prepared this oriented graph. And for this oriented graph, we have prepared the reduced incidence matrix. And in this reduced incidence matrix, I have taken this as a ground node or reference node. Again, it is not necessary to choose this node as a reference node. You can choose this node as a reference node. You can choose this node as a reference node, or we can select this node as a reference node and only delete that row related to that reference node. To begin with, I have taken this as a reference node. That's why I have not prepared the row related to that particular node. This is the given figure. For this given figure, we have prepared the oriented graph. For this oriented graph, we have prepared this reduced incidence matrix. I guess anyone should not have difficulty about this calculation, up to this calculation. Is it right? Because this is the general procedure I have discussed deeply and clearly in the previous lectures. Now I will proceed further. What is the next? Next, we have to prepare this matrix ZB, that is branch, we have to prepare not ZB, YB, that is branch admittance matrix. This Z name, I have forgot to remove it. This is actually the YB, that is branch admittance matrix. This is YB, that is branch admittance matrix. How is the branch admittance matrix? Now look at, this is 1 1, that is Y11. Actually, how will be the names? This will be the Y11, this will be the Y12, and so on. This is the impedance, admittance of the first branch. What is the admittance of the first branch? First branch is this, its admittance is 2. 2 more, or 2 Siemens is the 2 value. For the branch number 2, how is this admittance? 1 Siemens. Here it is 1 Siemens. For branch number 3, how much is this admittance? 3 Siemens, or 3 more. For the branch number 4, how much is this admittance? Its admittance is 1 Siemens, or 1 more. This is 1 Siemens or 1 more. Is it right? And for the branch number 5, its admittance is 1 Siemens. That's why it is 1 more. This here, in this case, the remaining entries will be 0, because branch number 1 is not common with the branch number 2. That is applicable to the loops or meshes. But here only we have the diagonal elements in this particular case, and remaining all elements will be the absence or 0. Is it right? Are you getting me? How to prepare this YB? It is not the ZB. How to prepare this YB? It is very simple. Hardly it will take less than 10 seconds to prepare this particular matrix. For the branch number 1, it is 2 Siemens. For the branch number 2, it is 1 Siemens. For the branch number 3, it is 3 Siemens. For the branch number 4, it is 1 Siemens. And for the branch number 5, again it is 1 Siemens. Which we can prepare this matrix very easily, which is nothing but the branch admittance matrix. Is it right? If these values are given as impedances, that is in terms of the ohm, in that particular case, we have to convert these values in terms of the admittances, and we have to enter those values here. Is it right? That is the philosophy in these calculations. Yeah. Now here in this case, what we will do, now reduce the incidence matrix we have, now we will prepare this YN. That is reduce the incidence admittance matrix. Using this equation we have seen. How is the equation? This Yn is equal to A into Yb into A transpose. This relation we will use. We will do this calculation. This is the matrix multiplication, and this matrix multiplication is not that much complicated. It is very simple multiplication. First we will write the A. What is this A? A is this reduced incidence matrix, which I have copied from the previous slide. Look at here. This is the A, which is the reduced incidence matrix, which is this. I have copied as it is 1 1 0 0 0 and so on. Here, in this particular case, this is 1 1 0 0 0 and so on. This matrix is the matrix A, which is the incidence matrix. This YB, I have copied this YB, that is branch admittance matrix from the last case, which we have calculated here. This value is actually, it is YB. This YB I have calculated directly as it is 21311. This value I have copied directly. This is 21311 and so on. This here, this is A I have taken here, which is the incidence matrix. This YB is this, which is nothing but the branch admittance matrix, and this is the A transpose, that is transpose of this admittance matrix, transpose of this reduced incidence matrix. Means its first row will become its first column. This is 1 1 0 0 0, then it is 1 minus 1 0 0, and look at here, this is the transpose of that matrix. Is it right? And when we have prepared about this, we will do this calculation. How is the calculation? Look at here, I will perform this calculation here itself. How is the calculation? This branch, row number 1 is multiplied with the row number 1, row number 1 is multiplied with the column number 1. We will add up those elements and we will write it as a first entry. Is it right? This is 2 into 1 is 2. This is 0 into everything, means its value will become 2. Here its first entry will be 2. Is it right? Are you getting me? This is 2 into this 1, 0 into this 1, this 0 into this 0, this 0 into this 0, this 0 into this 0, and addition of all these elements, and its addition is the 2. Then this first row and second column. How is the multiplication? Look at here. This 2 into 0 is 0, this 0 into 0 is 0. This 0 into minus 1 is 0, this 0 into this 1 is 0, this 0 into this 1 is 0, and finally this 0 into this 0 is 0. This is addition of those elements is again 0. Then next we will prepare the multiplication of this first row and last column. This is right, first row and last column. In that particular case, how will be the entry? This 2 into 0 is 0 and so on, and we will get those elements. Means if we are multiplying, I will write the conclusion here. If we are multiplying this first row with first column, how much is this entry? 2. If we are multiplying this first row with second column, how much is the multiplication and summation of the elements, which is 0, I guess. Is it right? This is 2 into 0, 0 into everything. Again, this is 2 into 0, but this entry will be 0. It is something like this. This was first row, all columns, this will be the case. Then we have the second row and this first column. That entry will be here. This third row and first column, second column, third column, those entries will be here. And then fourth row and this multiplication, that entry will be here. And finally, its multiplication with this entry will be here. Yes, we will get one matrix here. Is it right? In that particular case, now we will multiply this matrix with this matrix. Whatever the matrix we will get here, the multiplication of these two, that matrix we will multiply with this matrix. Is it right? And when we will carry out that particular multiplication, in that case, we will get finally this matrix. Here, I will discuss this multiplication in detail whenever I will cover this similar problem on the paper in that particular case, but due to the limitation of the space, I may not be able to do that multiplication part. But philosophy is simple. You are aware about the matrix multiplication. And then finally, we are in a position to find out this value of the yn, which is nothing but reduce the instance admittance matrix. Try to differentiate between the two matrices. This matrix is the branch admittance matrix, and this matrix, whatever we have obtained, it is the reduced instance admittance matrix. That matrix we have prepared here. This indirectly we are able to calculate this yn using this formula. If we are in a position to find out this yn, now look at, we have to prepare this is. We have to prepare this is. Now look at how is the is. For this first branch, we have this attached source. Its direction is downward and direction of this current is also downward. Though both directions are same, that's why its entry will be +4 because this current is 4 amperes. This entry will be +4. Is it right? Similarly, for the branch number 2, there is no source attached. Its entry will be 0. For the branch number 3, there is no source attached. Its entry will be 0. For the branch number 4, there is no source attached, its entry will be again 0. For the branch number 5, there is a source attached, but look at, this direction is downward and attached source current direction is upward. Now both directions are reverse of each other, that's why this value, which is 1 ampere, should be written as -1 ampere. Now look at what things we have calculated till right now. We have obtained the directed graph, then we have obtained this reduced incidence matrix, then we have obtained the transpose of it, transpose of the reduced incidence matrix, that is nothing but A transpose. Then we have obtained this YB, that is branch admittance matrix, and using these elements or these three elements, we have prepared this y or yn to be exact. That is reduce the reduced incidence matrix. That is reduced incidence matrix. It's admittance matrix to be exact. How is it? It is nothing but A into YB into A transpose. Using that, YB into A transpose, using this relation, we have prepared this YN, or whatever the name which I have given. Is it right? After that, we have prepared this IS, is the source impedance, source current matrix or current source matrix. Now here, now look at what we have done. We have prepared this YN. I'm revising again. Here, look at what we have done. I will go in one glance. For this given figure, we have drawn this figure. For this figure, we have prepared this oriented graph. For this oriented graph, we have prepared this reduced incidence matrix. For this reduced incidence matrix, we have prepared this YB, that is a branch impedance matrix. From this branch impedance matrix, using that relation, that is YN is equal to A into YB into A transpose, we have prepared the YN. And for this YN, after that, we have prepared this IS. Up to this, there should not be any difficulty. I will come back to you after completion of this particular problem. I will take your queries one by one. Then we will prepare this equilibrium equation, or we will take this equilibrium equation. What is the equilibrium equation? This YN into VN, which is equal to minus A into IS. This equation we will prepare. I will show this equation where we have taken this equation. If I will go back, we have prepared this equilibrium equation here. Look at this equation. We are interested in this equation. This YN into VN minus A into IS, we will prepare this equation, and from this equation, we are able to find out this value of the node voltages. Because this value is known, this is known, this is known, we are preparing the node voltages indirectly. Means the way which we are using in case of the nodal analysis method. In case of the nodal analysis method, first we will find out the node voltages. And then we can find out the branch voltages and branch currents later on. We will use this procedure. But first we will prepare this matrix, means indirectly we are trying to find out the node potentials. Look at how we will find out the node potentials. Here, in this case, we will find out the node potentials. This YN. I have copied this YN from the previous slide. This VN is the node voltages, which is Vx, Vy and Vz, which we have taken the three nodes. That is names I have given, that is A, B, C and D nodes, but D node is the reference node. That's why we have not considered for the D, but the names I have given here as Vx, Vy and Vz. This A is the reduced incidence matrix. This is reduced incidence matrix. This is minus sign I have taken as it is. And this IS is nothing but the current source matrix, which I have taken from the last slide. We will find out its multiplication. How is the multiplication? This first row, this first column, first element. How is the first element? This 1 into 4 will be 4, this 1 into 0 will be 0, and then this 0, then plus this 0, and then plus this 0, this will get its value 4. Then, in this case, then we will do this multiplication. Second row, this column. This is 0 into this 4 will be 0, this minus 1 into 0, this is 1 into this 0, then 1 into 0, then this 1 into 0, and finally 0 into minus 1, that entry will be 0 here. Sorry, this 0 here, this entry will be 0. And finally, this into this will be 0 into this 4 will be 0, plus this 0 into this 0 will be 0, this 0 into this 0 will be 0, this minus 1 into 0 will be 0, but this 1 into minus 1 will be the minus 1. Is in that particular case, its entry will be minus 1. And if we are multiplying by the minus sign, this will become minus 4, this is 0, and this is minus and minus plus, that will become 1. This is the case. This is the case. Now we have this equation. This 3 Vx minus Vy plus 0 Vz, which is equal to 4. Generally, we are using the directly calculator, or we can use the directly calculator to find out the values of the node potentials. Here, I can show you how is this calculations. Is it right? We can use this calculation and we can find out these values. Otherwise, use your calculator, enter these values, because generally we are arranging the equations in the matrix form. In place of this, if I am taking this column, this is how are the equations. Otherwise, I will discuss. Equation will be 3 Vx. How is the equation? 3 Vx minus Vy. Minus Vy. How much is the Vz? 0. I will not write. Which is equal to this element. How is this element? Minus 4. Is it right? How is the second case? This into this minus Vx plus 5 Vy minus Vz is equal to 0. That is the second equation. This 0 Vx minus Vy plus Vz, which is equal to 1. That is the third equation. We have the three equations and three unknowns. We can use the calculator and we can find out those values. Now look at here. If we are taking this calculation of the node voltage Vx, Vy and Vz, if we are using the calculator to this, we are able to get the value of Vx as minus 1.4 volt, and this is Vy as minus 0.2 volt, and this Vz as 0.4 volt. This here we have calculated the node potentials. Look at how is the methodology and what we need to give to the computer if we want to do its programming. We have to give the three inputs to the computer. What are the three inputs? We have to give the A. A is nothing but reduced incidence matrix. We have to give the YB, that is branch impedance matrix, and we have to give the IS, that is nothing but current source matrix. Only these three inputs we have to give to the computer, and the computer directly computes the node potentials. At the same time, it also computes the branch voltages and branch currents if those are included in the computer program. Is it right? And the program is general program. Here the thing which is going to change is nothing but the order of the matrix. If the figure is different, if we have the 5 branches, the branch matrix order will be 5 into 5. Is it right? If we have the 100 branches, the order of the matrix will be the 100 into 100. Accordingly, the column matrix order will be 100 into 1 and so on. Is it right? Is in that way. And when we know the node voltages, we can find out, look at branch voltages using this formula. Because this branch voltages are not known, this A transpose is known, Vn is known. Vn is nothing but node voltages. We have calculated the node voltages. And if we are doing this calculation, then we will get V1 as minus 1.4, this V2 as minus 1.2, this V3 as minus 0.2, this V4 as minus 0.6, and this V5 as minus 0.4 because this calculation. This V1 is equal to this row into this column. Means 1 into minus 1.4, 0 into 0.2 plus 0 into this value, its entry will be this and so on. This we are able to find out the branch voltages in this particular case. In the similar way, if we know the node potentials and branch voltages, we can find out the branch currents. Look at here. The branch currents are given by the formula YB, which we have already calculated. VB, node voltages or branch voltages, this we have calculated in the previous case itself. Here, these are the branch voltages. And using this formula, that is again IS, using this formula, that is YB, VB plus IS. This is YB, is a branch admittance matrix. This VB is the branch voltage matrix plus IS. This is current source matrix using this calculations. How will be this calculation? This I1 will be multiplication of this row with this column and addition of all entries plus this value will be this entry. Is it right? Means how it is? This I1 is equal to 2 into minus 1.4. That is minus 1.4. And 0 into all these entries, it will be minus 1.4 plus this 4. Is it right? This is minus 1.4. If I am doing the calculation minus, this is minus 1.4 plus that value which is nothing but 4, and now this entry will be, it is that way. Is it right? In that way. Sorry, I did the wrong calculation here. This is 2 into minus 1.4. How much is that value? 2 into minus 1.4, that value will be minus 2.8. This minus 2.8 plus this 4. Plus that particular 4, its value is 1.2, is this particular value. Means how much is this multiplication? This multiplication will be, there is minus 1. This is 2 into minus 1.4 is that multiplication. And if we have the elements, that elements need to be added. The care is taken by the computer if we are doing the software, but we have to solve this particular problem physically to understand this concept. That's why we will go physically.